It is an absolute pleasure to introduce you all to the speaker. Dr. Singh obtained his Masters in Zoology from DAV College, Dehradun, and his doctorate in Zoology from HNB Garhwal Central University. He has over 32 years' experience in sericulture research and extension management in different parts of India. He has been involved as principal investigator in national and international collaborative research projects. His research findings are published in national and international journals of repute. He has participated in many national and international seminars and symposia. He has been associated in implementations of flagship programs of Central Silk Board, such as National Sericulture Project, Catalytic Development Program, 11th and 12th Plan Period, Silk Samagra, and ongoing Silk Samagra 2. He was nominated as resource person by Central Silk Board for implementation of developmental projects in Northwest India. He has also served as National Trainer of Central Silk Board and Nodal Officer of Central Silk Board for development of mulberry plantations on sites of carriageways of national highways in Uttarakhand and Jammu and Kashmir. He has been associated in R&D collaboration with universities, organizations, and various international institutes. Further, he has been associated in imparting classroom and online teaching to university students of University of Delhi in colleges such as Miranda House, Dayal Singh College and Aurobindo College, Central University Jammu, Govind Ballabh Bhatt University of Technology and Agriculture, and St. Joseph University, Nagaland. In the first session for today, Dr. Singh will be speaking on hatching of eggs and Chawki silkworm rearing technique. Ladies and gentlemen, with a huge round of applause, please welcome our speaker for today. We welcome you all, sir, and over to you for conducting the session.
For giving such an elaborative introduction. I am Dr. Sardar Singh, as already introduced to you. Working in Central Silk Board for over 3 decades from now. Friends, my topic which has been given today for this faculty development program is Chawki rearing, hatching and other things. It is all integrated. So one by one it will come in the course of the discussion. I don't know whether the write-up is provided, madam.
Yes.
To the
man.
Okay. So I think the details of the concept and its all its activities has been covered in that e-manual which might have been provided to you. And I will be giving some of the hints and some practical aspect of that. We could have, because we all know that sericulture is, along with the science, it is more of a management sort of thing. So when we talk sericulture in general, we say that it is 75% management. So many things will be you can find in the various books, journals and the papers. But when you do it practically, you will have the real feel that what it is all about. So I think we will be very close to those practical aspects when we will be discussing about this Chawki concept or the techniques. Those who have conducted silkworm rearing for commercial purpose or even for academic purpose also, they might have seen that in the first phase of silkworm rearing, what actually happens is that we started with the silkworm eggs. Then, as we all know that in the entire silkworm rearing, we are having 5 instars. Then, out of that, first 2 or 3 we will say. The third is the intermediate instar, we call it. But the first 2 is very, very crucial. Generally, whenever we ask the student that which instar the silkworm grow maximum, generally we see the bigger size and the answer comes that it is the final and the 5th instar. But it is not. It is the first instar where we have the lot of development take place, and the second is followed by that. We all know that during its entire active life of the caterpillar, it generally does not change its shape. Its size changes. And it all happens right from when it comes out from the eggshell. So, brief about my organization and the Center Silk Board, because I just want to turn you up to the what we are doing in Center Silk Board. And it is the organization of the Government of India which is dealing with all sericulture activities and the policy making in the country. One of the oldest commodity board, and our main focus is R&D and the allied sector for that. We are having a collaboration across India with the academic institutions. In the morning when I came here, we have a discussion with the madam and the principal as well, that why University of Delhi cannot have such type of collaboration with Center Silk Board. Anyway, it is a policy matter, nothing to do with this FTA. But it will be good that if you collaborate in future also. Yeah. Now, silk, we all know that it's a protein fiber, and when we talk of this protein fiber, the question may arise that how this actually work. There are two protein substances which constitute the silk filament, that is fibrin and sericin. We will see the blend of it, and it is the purest form of protein, that's the silk fabric or the garment for that matter. You see this formation of cocoon. Initial phase, then the fibrin, the main fiber part of the silk thread, and its insulation by the sericin. This is electron microscopic structure. You will find it on net also. So you can see this is the fine silk filament, how it is made up of. In the beginning, it is the initial phase of when it has been given in the topic also that this spinning. This is the spinning worms. The initial phase, it is fixing somewhere, and it is the floss. What you can see in the picture, it is a floss. Finally, it will be turned out into a full compact cocoon. So just to create the continuity, that when I will be coming to the Chawki rearing. This is life cycle. We all know that, and we have studied it. All the students who are biological student and zoology student, we all know this. Now, this is the importance of silk in the sericulture industry ever since its discovery. Recent discovery is that it has been, the traces of the silk has been traces in the Indus Valley civilization literature, and we have challenged it that there is always a debate, because the most authentic documentation and the fully documented literature comes from the Chinese source. So it is believed that silk originates from China, but there is a Japanese book which refers that equal references are found in India also. Then who knows that it might be from India, where from it has gone to China. But we don't have that much like concrete chronological order. But what we find in the Indus Valley civilization, this recent finding that some sort of silk threads are there. It is now being published now. One recent book has been published by Center Silk Board when this Higgs index has been challenged, when the sustainability of the silk has been challenged by in USA. So that is a different altogether story. Maybe that some post-cocoon expert will be in a position to tell it more, but it has been now traced that it was a part of Indus Valley civilization. Then we may have a different story altogether about the silk. So, and ever since its discovery, it has been a part of Indian civilization and the culture. We all know that. There are many functions, many of this thing. And the feel, it is not only the fabric, but it's silk and the resham, what we call it in Hindi. Generally, we refer to the softness, sheen. The resham jaisa hai, it's like silk. So that is the importance of silk and the sericulture as a fabric and as a part of our civilization since centuries. This is the silks of India. Sorry. silks of India, we all know that we are the only country in the world where we have the all five. I am showing it four only here because one, the tassar is the two types. It is one the temperate and the tropical tassar. So all five in that, for that matter, all five commercial variety of the silk is exploited in India. We have the monopoly over muga in the world. There is a costliest silk called the golden silk. It is confined to our northeastern region. It has been tried in other part of the country, but the success is not that much for the commercial exploitation. But yeah, it is there that today we are the second silk producer country in the world. Once the gap was very huge, but now it is narrowing down. So these are the all cocoons, and it is the host plant and the insect for different variety of the silk. This is mulberry, then the tropical, then the temperate tassar I was, because we have a Antheria milita for tropical and Antheria proeli for temperate. Oak we call it. The Quercus species, because it is the only this tropical and the tassar which is combined, generally called with tassar. And from mulberry down to the mulberry, all these silk are termed as the Vanya silk, wild silk. Out of this, area to a certain extent is being domesticated, but the rest of these three is totally wild. You will have to conduct the silkworm rearing in the wild form in the trees itself. These are the different parts of the India where we find this all type of silk. If we talk of this muga, it is confined to the northeastern part, and mostly the silk order in India, in entire world, is dominated by mulberry silk. It is around 95% of the entire silk produced in the world comes from mulberry. But we have equal importance and the scope for further commercial exploitation of the wild silk as well, because in textile industry, from fashion point of view, there are so many products which is on tassar and eri based. One of the feature of the eri is that it is called the Ainsa silk, because we have a different faith and religion in our country. So many people used to say that silk, because we kill this pupa, so it is not something to be done. But as we all know that it's almost, when it transforms into a pupa, it's life is there, but nothing beyond that. Even for that matter, in the tree and everything is living. It is living, but it cannot move. And life, silkworm has a certain specific period of life. Beyond that, it cannot go, even if you left it to open also and the wild. Means you don't cook it for extraction of the silk thread. Now the Chawki concept. Actually, what was happening earlier on, why this Chawki concept come into practice? Just for the commercial importance and to have a robust silkworm for the later stage of rearing. That is the fundamental of Chawki. Chawki means initial two instars, being the most vulnerable to the environmental and hygienic shocks, and requires quality mulberry leaves and meticulous planning for silkworm rearing. If we manage, it is experimental findings, if we manage it properly, then 60% crop is in our hand. Means we will have a better robust silkworm for the final instars, and it can withstand with the shocks and the adverse climatic conditions if there are certain changes. Even it can fight with the pathogens if they are robust during these two instars. So as on date, how it is being done in commercial level and as well as the R&D organization. Generally what is happening, the Chawki, the directly seed is not being supplied to the farmers for better commercial outcome. It is the Chawki worms. Sorry. Yeah. So when the Chawki is conducted, then the worms is supplied to the farmers, those who are doing it for the commercial purpose. And So there is a entire planning for that, how the Chawki should be conducted. First, if the Chawki has been conducted properly, it means that we are giving us better or the qualified worms or the seed, you can also say, to the farmer, and it will ensure a better crop. And if the crop is better, then the next time the rotation will be followed, and if the crop fails, generally farmers will ask certain questions. From the commercial point of view, and even if you are doing in the lab also, if you do not have a better planning, then the worms will die, say in fourth instar, or will not dispense the cocoon. So this is the importance, that why the Chawki is very, very important. And in technical terms, the silkworm rearing up to second instars, some may call it to the third instar always, if it is done, but it's then commercially become more expensive. So if it is done up to second, it will do, but if you can do it up to third, because the same management is required for the third instar as well. Now, importance, which I have already mentioned, it will ensure that we have a better crop, good yield of cocoon, and it also reduces the production cost. How? Because if the Chawki is properly conducted, then the lifespan of the silkworm will be within its natural life, means within 25 or 26 days it will spin the cocoon, and if the Chawki is not properly done, it may go up to 30-35 days. Worms will not die, but this rearing period will increase. So what will happen, that there will be more labor input, more leaf, more management, so it is not economically viable. So better Chawki means only if we have a 25 days crop, we will harvest the best cocoon. The further it is delayed, because silk gland will be active from the fourth instar onwards only, not before that. So if it go further, then the quality of cocoon is compromised, and we don't have a good harvest. So very, very important concept. In the entire silkworm rearing, it is the backbone, if I call it, that how best we have conducted the Chawki or the CRC called the Chawki Rearing Center. So how best we have managed the CRC, the Chawki Rearing Center, will speak all about our success of the silkworm crop. Maybe that it might have been, you have read it earlier, or Dr. Dandin has given this figure. This is the very old Japanese finding, and it is still believed to be the perfect one. That climate in the mulberry leaves is the biggest contributor for success of silkworm rearing. It doesn't mean that if we have a poor quality of seed, then the contribution will come from the leaf and the environment. No, it is not like that. You can just assume that when we talk about the mileage of a car or this bike, it is under the standard rearing condition. Means all other parameters are intact, all the desired parameters. So this comes the contribution like this. Means seed should be perfect, race should be perfect as per our environmental condition. Suppose we are having a very hot climatic condition and we are rearing with the Bible time, then this finding will not work. Yes, it is a congenial climatic conditions. We have every other factor is intact, and we have procured the best race, say for that Bible time race. Then the climate of the contribution of the climate of the mulberry leaf will be somewhat around this. Means if we are feeding a good mulberry leaf, and also have managed the climate, means inside a rearing bed or the rearing room. Even the microclimate of a rearing bed contributes a lot. So this is the important activities or the protocols which you have to follow for a success of a silkworm rearing. Yeah, just for your interest, again, because why I am quoting Japan. You know that as on date, China is the largest silk producer of the raw silk in the world, but once it was Japan which was the scientific research which has been conducted in Japan for sericulture is still as much relevant as that time. Recently we had a conference in Bangalore and one Japanese scientist was there. He was with me only. I asked him that what is the condition of sericulture in Japan. Now in my private conversation, he told me about 150 persons are doing it now. See this. And once before the Second World War, silk was the main revenue source for Japan. So it is a labor intensive industry. More mechanization will be there. There will be a tough to sustain the sericulture as in the labor intensive package. Why it is happening in China? Why it is coming down? In 2015, Chinese production was 1,70,000 metric ton raw silk. It has come around 50,000 only as on date. Impact of mechanization again. So there is an old saying that all mulberry will not yield cocoon. It means that depends on the quality of mulberry which you are feeding in. Has also a huge role in the success of a crop. And mulberry leaves used in Chawki rearing covered about 50% of the cause of the bad silkworm crop. Means what type of leaf we have used in the mulberry, the Chawki, will decide the fate of the entire crop. It is further reported that under the same environmental condition, there will be a different outcome. So, what does it say? That we should have a season-specific planning. If we are conducting silkworm rearing during the spring, we should have a different. If we are conducting in autumn, we should have different programs. If it is in summer, means the rearing management, shift in rearing management, not that the different trays and equipment all together, but there should be a planning like that. That I have already discussed. Now this is the Chawki leaf requirement. Leaf moisture about 80%. Leaf protein and carbohydrates we cannot measure, but if the leaf moisture is good, this is a good indication. If we pluck a mulberry leaf from a garden, just rub it in a palm, and after that if it become green, means there is a moisture. If it has been turned out into a dust and it fell down and there is no green portion in your palm, see that the moisture is very poor. That you can easily measure, because every time we cannot have this biochemical analysis. And if you have given the total input, what is the recommended input for a mulberry garden, then the leaf protein and the carbohydrates will be intact in the mulberry plant. Importance, because crop stability is one of the main feature of the Chawki rearing. I will show you that Chawki rearing in India has now in recent time has come up as a commercial venture. In South India, a farmer is conducting Chawki only and they are selling the silkworm seed. But as on date, if we talk about the North India, including the Uttarakhand, UP, Haryana, Punjab, Himachal, we are managing around 50% only. The what we call the exact Chawki rearing condition. But in southern India, it has gone up to 70-80%. That's because the productivity is more in the southern states as compared to our state in North India. It totally being decided by the Chawki practices. What we required for Chawki garden? First requirement is the Chawki garden. Means what is being utilized for the latest rearing is not applicable for the Chawki rearing. We will have to maintain a proper separate garden for Chawki, and if we don't have that much of land, then a portion of land of the existing garden has to be managed as per the Chawki requirement. How can we do that? That can be done that whatever the means, we have a garden where we can sustain 50 DFLS. 50 DFLS means around 30,000 worms. If we have a planning for that, then 1/6 of that entire garden is required for the Chawki. That you can estimate that this portion we will utilize for the Chawki purpose only, and the rest will be utilized for the late age. We will just find out in the picture also if it is there. There are different varieties for Chawki. In North India, luckily we are utilizing one for the late age and as well as the Chawki also. That is S146. That is the recommended variety as S146. Second variety is S1635. Both these varieties are recommended for Chawki as well as the late stage. But in South India, S36 and VN varieties are very popular. So it means that different silkworm varieties has been developed. So that should be exploited if you are going to establish a Chawki garden either in university or college. And that is there. Then entire establishment, I think those resource person who have taken the mulberry classes might have given the information about this, that how to establish a garden, what is the input applications. For Chawki, it depends on that how many times we are conducting the silkworm rearing in a year. So the garden will, the input will be according to that. Because in southern India we are having 4 operations, even 8 operation, but it's a batch. They make a certain batches that from the garden this much portion for this because the climatic condition is better there in certain part of the southern India. Where in North India we cannot conduct rearing after October because the leaf senescence will be there, the mulberry will be shed of the leaves and it will be reload only in the next spring. So this period is almost like there will be no leaf on mulberry or it will be a very few leaves. In December and January virtually there will be no leaf. So accordingly we can manage. That information can be provided later on, so I will not go into detail of that. Only thing is that if we apply this FIM, because FIM is a very important, the chemical fertilizer will depend what is the soil health of that particular plot. But FIM can be applied. We will have the double dose of FIM as compared to the commercial garden. The Chawki is required. Suppose we are recommending 10 metric ton per hectare of FIM, then the Chawki will be 20. If we are having 4 operation from the same garden, then we will go to the 40. It depends on that how the intake is from the particular garden for CRC operation. Maintenance of Chawki garden is like any other mulberry garden, weeding, digging, pruning. That has to be done practically, because if I say something here, it will not go right inside. We will have to maintain the crown height minimum at the 1 feet. Then the branches will come up, then again to prune and to maintain the primary crown. Then hereafter the pruning has to be resorted only on the primary crown. We cannot come down from the primary crown level. If you come down, the next year there will be a shortage of leaf. Then if you are conducting the spring crop, how to harvest the leaf, and if you are conducting autumn crop, how to harvest the leaf, so that the next spring we have a better leaf. Yeah, that is the pruning. 20 to 25 means around 30 centimeter. In nutshell, we can say up to 30 centimeter. The first cut should be given. Means if you are raising a mulberry garden and we have to maintain it as a bush, there are 2 types of practices. One is tree, and because mulberry basically is a tree. For commercial use, it has been brought down to a bush. So, if you give a cut and want to make it a bush, then the first cut should be around 25 to 30 centimeter. After that, within the next 6 months, there will be branch coming out from the crown. That minimum 5 to 6 or 7 branches should be left at that crown. And if it is the winter, then cut it from 1 meter from the primary crown. And if it is a summer or monsoon, then the 6 to 9 inch from the primary crown. That cut has to be resorted to make it a better plant for the future yield. Land plowing, weeding, organic manure, which I have already discussed, 20 metric ton hectare in 2 split doses in our condition. Means if we are having 2 operations, then we will split it into 2 doses. Chemical inputs, it is slightly on higher side. In North India, including Delhi, it should be 200, 100 and 100 NPK for Chawki garden. In subtropical conditions, it is slightly higher in temperate than what we do in Kashmir and all. Irrigation is very, very important for a Chawki garden where we are conducting the Chawki, because the duration of the Chawki will not be more than 8 days if it is a good Chawki. It may go up to 12 days, but that means something has been compromised, either the feeding, the quantity and the quality of leaf, or the bed spacing and the overall layering management. If it goes beyond that, then it will take time. During that 10 days, say the spell of 10 days, we will have to irrigate it at least 2 times. Because only then the required moisture of mulberry leaf will be maintained. So the Chawki garden has to be irrigated more as compared to the late stage. During the late stage, if once it is irrigated or twice it is irrigated for entire, for 15 days, it will do. But during the Chawki, if there is a natural rain, okay. But if it is not, then we will have to irrigate it. Yeah, yield generally will depend on how the plants has been maintained. So this is the projection for north condition, around 15 to 1900 kg from 2 crops in a hectare of land. But it depends on that how much we required for each rearing. What is the quantity of seed? That is again the same figure related to that only. Yeah. We will consider it under subtropical condition. So, this is the ounces. Ounce means 1 ounce is equal to 100 DFLS. So, the 75 will be 7,500 and 80 will be 8,000. This is the quantity of seeds which can be Chawki reared from a hectare of land. Again, it is a mathematical calculation that what is the number of plants, what is our seed intake, how we are going to utilize it. This is the projected figure that this much quantity of leaf can be produced and this much quantity of DFLS can be reared. DFLS means disease-free layings. In Central Silk Board, because we cannot supply any seed which has not been certified that it does not contain any egg-borne disease. That is called the disease-free layings, DFLS. If you give a supply order to Central Silk Board, you will have to write this terminology only, 100 disease-free layings. When you call the 100 DFLS, it means around, by weight, it comes in a box of half, some 50,000 to 60,000 worms in 100 DFLS by weight, because it's around 30 or 35 grams. Depends on that when because it is industrial and the loose seed. Earlier it used to has on egg sheet, but now it is coming into a loose form. So by weight it is generally done, and if we have a box of one box which we will receive if you indent it from Central Silk Board, it will contain 50 DFLS only, and the weight will be around 16 to 17 grams by weight. So 2 boxes is required to complete 100 DFLS. 2 boxes, not 1. It will be required 2 boxes because 1 box comes with 50 DFLS only. Now we should have a building for that, because CRC building generally should be a separate one, because we require different climatic condition. If it is separate, it's okay. If it is not, then a room where we are going to conduct late age rearing, that can be initially used for Chawki rearing also. So if we want to go for a like 5000 DFLS, this will be the room size, 30 to 40. One anti room is required, but if it is not, it will do, but one room at least is required where you can have the incubation. A small room is required for incubation purpose only, because initially you will have to incubate the silkworm seed. And later, when the brushing and the hatching has been taken place, then it will be shifted to a rearing room. But if it is not there, we can use the same room for incubation and for the rearing as well. So this is the dimension of a Chawki rearing building. If you want to have a commercial rearing for 5000 DFLS, but if you want to have a demonstration purpose, then any room of 10 by 10 size, 10 by 12 size, it will do. And only thing, we should have a cross ventilation, and we should have a roof in a way that where we can have a thorough disinfection, roof, wall and the floor as well. That much requirement is only. And we should have a where we can keep heaters if the temperature is low, and we can keep the rearing appliances, because the rearing appliances of the Chawki and the rearing has to be disinfected first. Then once it is kept inside a rearing room, it should not come out till the complete rearing is over. This is the Chawki garden. In North India, you can say this is the Chawki garden developed by out of my experiment only. So this is the bush garden. The variety is S146. So this should be the height of a Chawki leaf, Chawki garden, if you cut it at the 1 feet. And this is also a commercial CRC garden, the bigger one. This is the inside a Chawki room. What I was talking about, you should have a stain trays and all, but before the arrival of the seed, it should be thoroughly disinfected. There is a recommendation for that what should be the quantity, what should be the quality, how it is to be done. These are the integral part of silkworm rearing. I have mentioned in my write-up that how it can be done, but this is the practical, because once it has been done outside, tomorrow if I find time in the morning, I will show that disinfection methodology. It can be a sun drying as well, then certain other method, but once it comes inside a rearing room, this is the final disinfection going on, a fine spray of the disinfectant on the trays. After that, the silkworm seed will come and put in these trays. This is the egg I was talking about. Now it is not coming in the egg shell, it will be removed from here and put in an egg box. But it will be it is the same thing, laid down in the same pattern, but removed from the egg sheet, and for the commercial utilization, for transportation purpose and all, it is put into an egg box. Now it comes in a loose. Now when it comes to Chawki rearing center, we will have to spread it like this only, either in a frame, or we make a paper for that, box type. We will have to make it very uniform, so that it is incubated properly and the embryonic development is very uniform. This is the hatching, means it has come out from the eggshell. There is a time for that. In a hibernated bivoltine egg, you will see that there is a color change, and it takes around 10 days. When means when it is released, date of release and the date of hatching, between around 10 days. So we will have to plan it accordingly. Suppose we have indented the seed from a seed supply agency, and we have request them that our date of brushing or the hatching, that is called the brushing also. Generally, we call it date of brushing. Brush means we use a brush on the top of it to remove the tiny silkworm from the egg sheet and put it in a tray. That is the brushing, to use with the help of a brush. So if we say that our date of brushing will be, say, 10th of August, that will be intimated to the seed supplying agency. They will release these eggs from the cold storage on around 1st of August. Then it should reach to the destination as early as possible, because that you will have to initiate the incubation. As early as it is received at a CRC or the Chawki rearing center, it will be properly developed, the eggs, and hatching will be better, worms will be healthier. So this time management is very, very important. This is the brushing, as I was talking about. What they have done, this is again from my own experiment. What they are doing actually, the eggs are on a sheet. It has been incubated for a certain period of time. There is a technique called the black boxing. I'll just explain. We cover it before the 72 hours of hatching. It is covered with a black cloth for a proper and the uniform embryonic development and the same day hatching. So when it is open in the morning, we put a net on this called the brushing nets. And when it comes up the nets, we will put like the choked mulberry leaf on that net. So we pick that net and put it to a tray. That time again we brush it so that there is a separation from the eggshell and the larvae, separated from there. This is the mechanism, right? These are the Chawki worms. And these are the mature worms. The silk gland generally gain the size from 4th instar onwards, and it increases by 10,000 times. So shape is the same, but there is an increase in the size. This is the leaf harvest from a Chawki garden. We harvest only the top leaves. From the top glossy leaves, what we generally do, we will hold it like this, the mulberry plant on the top, and you will find that one tip is there. Catch that tip and hold that leaf, and beyond that leaf, start the plucking from the top, then the second and up to third. Harvest 1 to 3rd leaf. First to 3rd leaf has to be harvested for Chawki purpose. For the first instar, and from 3rd to 6th for the second. So if you go to any R&D organization of Central Silk Board and Chawki is going on, you will find that what is the instar of worms if the leaf has been properly plucked. Do not pluck the entire plant for at the time of Chawki. These are the requirement. I think it is given in this manual also. So what should be the requirement for 100 DFLS, 5,000 DFLS of a Chawki? So we can calculate, if we are conducting only 50 DFLS, you please calculate out of it. Some of the basic things will remain same, that the bucket and these small things, this dry weight thermometer, it will be required, either you do more or less. But the rearing stand and rearing trays and the quantity of disinfectant will depend upon the size and the volume of the rearing appliances. Rest will be almost same. Bed cleaning nets will also be depend on what is the quantity of seed that you will have to procure. Now this is the instar wise, as I was talking about, that it should not go beyond 8th day. 8th day is the distribution day when it given to the farmer for this commercial rearing. And if it is done in the institute, suppose in this college or anywhere else in Delhi University, for that matter it has to be, it will go inside the same room only. When we will be discussing the late age, then it will be in continuation to that only. 23 kg of leaf is required for 100 DFLS rearing for the up to 2nd instar. So in because this is a means the scientific type of calculation, so you just calculate around 25 kg. There will be some wastage and all. So spacing starting May, you will see that how it increase. The tray, when we call it is standard tray. 2 to 6 trays means one tray is the dimension is 2 feet by 3 feet, then 6 square feet. When we say 6 trays, then it is 36 square feet. When I say 12 tray, it is 76 square feet. This is the number of trays. This is the plastic trays of standard size. Now disinfection, we'll discuss it tomorrow as well, that if we want to have a preparation of 100 liter solution, say for bleaching, this bleaching powder is the primary disinfectant because generally we can find it anywhere, bleaching powder. Second one is the chlorine dioxide, generally marketed in the name of Serichlor and Sanitac. These are the two recommended disinfectant for silkworm rearing. Complete disinfection after each CRC operation. This is good for latest rearing also. Wherever we have conducted the silkworm rearing, generally what we do when we start the rearing. But post-rearing disinfection is more important. It has to be done immediately when the rearing is complete. Otherwise, there will be a pathogen load for the next crop. Equipment and building at least 3 days before the arrival of seed has to be thoroughly disinfected. After that, the room and the windows should be closed. Only 24 hours before the arrival of the seed, it should be opened. But nobody should enter there with the slippers should be different. There should be a fine layer of the lime powder at the doorstep, so that when the slipper is which has been used, first you put it on the lime bed, then enter the rearing room. Hands should be properly washed before touching any tray or any material being used for the silkworm rearing. That is good for the rearing also. Whenever we are giving feeding, our hands should be properly washed with the soap. Whatever we are doing, complete one exercise and one act at a time. Do not mingle it with and overlap it, otherwise there are chances of pathogen inoculation. If possible, to double disinfect 2 days of the brushing. That is there. If we have once disinfected in rearing room and the rearing appliances, before just arriving of the seed, if we go once more, only with this bleaching powder, that will protect the crop. Now, for the Chawki, Vijeta is the bed disinfectant, but when we do use it, when the worms settle to the first mold and before resume for the feeding for the second mold, the Vijeta should be used. Vijeta otherwise we do not use during the entire instar. It is after the mold and before the resumption of the second instar, it should be used before feeding. Whereas the lime we dust over the molting worms. The fine layer of lime is dusted when the worms settle to the mold. That I will explain tomorrow when we will discuss molting. Then for the second instar, when the molds are settling when the worms are settling for mold, we will have a fine layer, the fine dusting of the select lime when the 90% of the worms have settled to mold. This will dry the bed because we require reduced humidity during the molting, and also will reduce the pathogen attack. But again, after the second mold, we will use the Vijeta for the assumption and before it enter into the third instar. So this is the two method of using it, and a quantity is given. This is all for 100 DFLS. 100 DFLS means as on date, earlier it was in so many books it might have been written 40,000 worms, but it is now changed. This has been standardized to 60,000 worms now. Black boxing and for synchronized hatching. I think I have already mentioned it. When you see the development of an egg, you will see that there is a color change. Earlier it will be something brownish if it is a diposed egg, or if it is of a multivoltine egg, then it will be yellow. It will change to blue, slightly blue. Then the time will come when there will be head pigmentation. Means there will be a small dot at the corner of the egg. That is very, very crucial to identify, and you can identify it with the experience. Generally, for the incubation, when we do incubation during the CRC, we should have a light for 16 hours and the dark period for 8 hours. But during the black boxing, it will be entirely dark room. There will be no light at all. It takes around 48 to 72 hours. It will depend on that how the growth has been taken place. For that, we can keep a small sample inside a room in a corner of a tray. So after 48 hours, you once check it. Check it means bring it out from the room and put it on a table and under the light. If the worms started hatching, coming out from the eggshell, it means it is ready to be opened. And if it is erratic, not proper, then don't open it on that day and wait for the next day. This is the mat requirement. The temperature during the first instar from 27 to 28. Second instar slightly reduced by 1 degree centigrade, and humidity is very, very important. It should be in between 280 to 85. Now one a practical input which I would like to give, that go 28 up to 28 only when you have a controlled devices. If you are going hitting with the coal and all, it may shoot up because you cannot control it that time. And if it shoot it up and it remain there for 30 degree or so, or 32 or 35 degree, it goes there. There are every chances that in the final instar we will have the serious incidence of grassery. So if you have controlled this, suppose you have air condition there and you have put it there. So better to go at 28 degrees centigrade because there will be auto cut. If it is not auto cut, my suggestion will be check it around 26 to 27 and try to reduce it down at that time only. It should not come down by 25 during the Chawki. In the late instar, should not come down because 20 degrees centigrade, because below 20, the physiological activities of silkworm got affected. So it should be keep in mind that if it is, say, very cool, in spring sometime it may happen, then we will have to give a heating device, say heater or blower. Put the temperature at the desired aim, then put it off. It should not be continuously till it is not auto cut. So these are figures are there, but generally from our side on low or technical officer, what they will shoot up to the 28 degree, did not control it there, and it go beyond that. It become problematic. This is I was talking about. This is not bivoltine egg. This is not hibernating egg. This is multivoltine. It will be like that only. It will turn blue before hatching. This is the blue stage of egg. That time only we will have to go for black boxing. Head pigmentation will be there for 2 to 3 hours or 4 hours only. That has to be catched. If the light has been conceived by brain and you go for black boxing, there will be erratic hatching and worms will hatch inside a black box. So that is again very, very important that we catch that stage practically, because it is not, because after seeing only this will not do. You will have to go it for at least for practical once. Then only you will in a position to see the head pigmentation stage and the blue stage of eggs. This is the black boxing. This is the pictorial presentation. That is the black cloth covered over the eggs and no light inside the room. This is the incubation period when we or the brushing. For incubation also, this is bulb, not a good photograph. We should have a diffuse light. Better to have a tube light, not a bulb. This is again the cutting of leaf chopping. We will have to cut it initially, because in the initial, after coming out from the eggshell, silkworm develop the sense or the appetite within 2 hours. Initial there, it will be only the sucking of the juice from the leaf. So it has to be cut. Later on the full leaf can be given. This is the brushing. This is a feather being used for that. This is the bed making. There is a foam pad Foam pad again, that if you are using foam pad, then it should be thoroughly disinfected for each rearing. Put it in a disinfectant not less than 10 minutes. If it is not possible, don't use it again. Otherwise, it is a big source of contamination. Otherwise, put a newspaper around, wet newspaper. थोड़ा सा उसमें मतलब पानी डाल करके, then make a round, and this is for humidity only. If the humidity is okay, during autumn crop we will not require it in Delhi also. But if it is a spring crop, when the humidity is less, then it is done. This is again how you should plug the leaves, which I was explaining earlier. This is a very, I don't know who is the person who has made this photograph, and for last 20 years it is being used. In all presentation, we should thank to that person. It has been published by me, he or she, everywhere. So I generally put it last and put my own photographs first. This is the leaf preservation, again very, very important. Generally what we do is wrap the mulberry leaves with the wet gunny cloth. That is the best method. And before feeding, we should just open the leaf bed to release the heat, because there is a heat inside a heap of the mulberry leaves. Hot leaves are very, very dangerous. Only it result into the BM NPB incidences. So please do that only the cold and natural mulberry leaves are fed with. This is the preservation techniques. This is again also very old photographs, so many people will show this. This is the leaf chamber actually, covered with gunny cloths. So it can be on a leaf floor itself. Have a proper cleaned floor, then put a gunny cloth, sprinkle water over there and put the leaf and again cover it there. It can have a masculine cloth as well, depending upon. This is the cutting of mulberry leaves inside a Chawki room. This is again a part of practical. You might have seen that they are covering the leaf at the corner. Now this is the hand cutting, but now we can have there is a machine for that. Leaf chopping machine. It has been developed by Center Seal Board only, and it is available. You can purchase it. These are the trays. Earlier it was wooden trays. Now it has been replaced by plastic trays. Some are wooden trays also there. Cleaning. No cleaning during the first instar. Earlier it was recommended, but now it is not, because to avoid the missing larvae. Only we spread the bed before the settling of the mold, so that there is a proper wet drying and the humidity is reduced. Two cleaning during the second instar, once during the feeding and once just before the settling of the second mold. There are two recommended cleaning. Use only cotton net for bed cleaning. They are recommended size of the nets. It should be used, and hand contact must be bare minimum with the worms to have a better rearing crop. This is the dusting I was talking about, lime dusting before the settling of mold. When the 90% is settled, we will have to dust this lime, and from third year instar onwards, if possible, dust every day before a feeding, once in a day. It is a excellent disinfectant, very cheap, readily available. We required around 10 kg of lime for 100 TFLS. 10 kg of lime means around 200 rupees only. If nothing is available, go with the lime application. Only the select lime. Do not apply it in the crude form. How it is made, that you brought from the market, sprinkle the water, gas will be released, then broke it down with the help of anything, any hard matter, then put it in a cloth and have this musculine cloth and dust it. This is the excellent disinfectant for bed cleaning and the pathogen load reduction inside a rearing room. If the humidity is very high inside a rearing room, say during the autumn, then you can have a fine film or the layer of the lime inside the entire rearing room. It will absorb the atmospheric humidity. This is very good, very cheap. And whatever the formulation has been recommended by us also in Center Seal Board. It is 90% lime base. So very cheap and best, this lime dusting. It can be done during molting, it can be done during feeding, but when there is not active feeding, when the worm says stop the feeding and before the next feeding, and next feeding once the lime is dusted should be given after 45 to 1 hour. By that time they should revolve into the lime. Even when this BM and NP incident take place, what we have done actually to dip the mulberry leaf in a lime solution, dry it up and feed that. And I have seen with my eyes that polyhydra colony is blasted like a balloon inside a microscope with a drop of lime when given on the polyhydra colony. So this is very good actually. Some tips for better Chawki. Leaves to be harvested from exclusive Chawki garden. Harvesting should be done in cool hours, either in the morning or late in the evening. For the latter day period, it should be preserved. 3 feeding in a day. Don't go for 4 feeding for Chawki. It is recommended somewhere 4, but 3 is good. But we will have to maintain a time for that. Means there should be a fixed timing for the Chawki, for the feeding. And larvae to be distributed if it is going out of the, like your CRC or lab, then it should be distributed in 12 trays. Means when it comes out of the second mold, the larvae should be in 12 trays. Hygiene we have already discussed. Now, how do you see that the Chawki has been done and what is its impact? High growth rate, but only 6% of the total mulberry leaves is consumed up to third mold. So do not waste the leaves during Chawki rearing. That is again a very important thing, because generally we overfeed the worms that time. Body water content is very low in newborn larvae and increase rapidly up to second instar. Need of high moisture and succulent mulberry leaves only. So if we pluck it from the top, it will be succulent, and if it is properly irrigated, the garden, then there will be moisture. No other science is required. Judge the CRC performance. Suppose now we have conducted the CRC, and before it is going to the third instar, we will judge that whether we have we have done it properly or not. The missing larvae percentage has to be around 5%. If it is above that, it means that the Chawki rearing was not proper. That is the one indication. Then larval uniformity. If the percentage of undersized larvae is 15% or more, it means Chawki is not proper. It will adversely affect the latest output. Take weight of 10 randomly calculated this undermold larvae, 100 larvae. If the weight is around 3.5 grams, then we can say that the Chawki has been done properly. These are the 3 parameters we check that Chawki has been done properly or not. With this we can find out that whatever we have done, either our spacing, feeding, timing, everything, if this is the outcome on the 8th day of the CRC operation, it will give us an indication that it has not been done. If it is not so, then we will have to have a retrospection that whether the feeding was given timely, whether the worms are underfed, or some other factor has contributed that has to be checked for the next rearing operation. Thank you.